Okay, let's unpack this. Welcome to the deep dive. Our mission, as always, is to cut through all the noise and get straight to the core insights distilled directly from the source material. And today, wow, we're taking on something huge. A really fast, but hopefully thorough journey through the whole sweep of Indian prehistory. We're talking millennia here. Starting with, the very first crude stone tools from maybe 2.5 million years ago, tracking how cultures evolved, right up to when iron use became widespread and transformative. It's a massive arc, earliest hominoid fossils, all the way to the foundations of the historical period we know. We've got a really comprehensive stack of sources for this one, covering everything from high-tech dating methods to paleoanthropology, the study of early human fossils, and even ethnoarchaeology, which is fascinating.
It really is a colossal timeline. I mean, the entire history of human presence in the subcontinent is almost hard to wrap your head around. But before we even get into the cultures, the tools, the art, we absolutely have to establish when all this stuff happened, to really appreciate the scale of, say, 2.5 million years, we need to get grounded in the methods, the archaeologist's toolbox, basically, for setting that chronological stage.
Right. That's a great point. It's kind of staggering when you think about it, all this complex science, the chemistry, the geology. It's just the foundation, isn't it? It's like the calendar we need before we can even start telling the story. So how do archaeologists measure that kind of deep time?
Well, we rely on two main kinds of techniques. First up is what we call absolute dating. This is about getting a fixed, measurable chronology, specific date range. The most famous one probably is carbon-14 dating, or C14.
Ah, yes, C14. Heard of that one.
Yeah, it's super useful. It's reliable up to about 50,000 years ago, which makes it incredibly important for the later Stone Ages, the Mesolithic, Neolithic, and definitely the Metal Ages. How it works is pretty neat. When any living thing dies, the carbon-14 isotope trapped inside it starts to decay back into nitrogen. And it does this at a very precise known rate. By measuring its half-life, which is 5,730 years, we can calculate how much time has passed since the organism died.
Okay, 50,000 years is a long time, but we're talking about periods going back millions of years. So if we find, say, a really old stone tool or pottery that's way older than 50K, or if the material isn't even organic, C14 is kind of useless then, right?
Precisely. That's a really significant limitation. It only works on organic matter, bone, charcoal, wood, shells, and only within that time frame. Contamination can also be a big issue. Now, for getting really high precision on younger sites, especially where wood survives well, we sometimes use dendrochronology, tree ring dating.
Tree rings, okay. How does that work?
It relies on the fact that trees produce unique patterns of ring widths each year based on climate. Wider rings in good years, narrower in bad years. By linking up the patterns from multiple overlapping wood samples, maybe from old buildings or preserved logs, archaeologists can build these long chronologies. It's like fitting together pieces of a puzzle, and you can sometimes get accuracy down to the exact year.
Wow. But like you said, wood surviving from the really deep prehistoric periods we're starting with today, that's pretty rare, I imagine.
Extremely rare in most contexts, unfortunately.
Huh.
So dendrochronology is fantastic when you can use it, but not so much for the Paleolithic.
So, okay, let's get back to that half-million-year-old lower Paleolithic site. How do we date something like that? We must need methods that work on, geological timescales.
Absolutely. For those really deep dives into time, we have to turn to methods that work on much older materials, often volcanic rocks or minerals found in the same layers as the artifacts. Potassium-argon dating, or KR, is absolutely essential here. It measures the decay of a radioactive isotope of potassium, K40, into argon gas. Now, K40 has an incredibly long half-life, 1.3 billion years.
Billion, okay, that's more like it.
Exactly. That makes it relevant for dating sites that are hundreds of thousands or even millions of years old. We're usually dating layers of volcanic rock or ash that are stratigraphically related to the artifacts, maybe a layer above or below them. We also use fission track dating. This works on volcanic glass like obsidian or certain minerals. It basically involves counting these microscopic damage tracks left behind by the spontaneous fission or decay of uranium atoms that were trapped inside the material when it formed. More tracks mean it's older.
Okay, so that covers the fixed calendar part, the absolute dating. But you mentioned there's another approach too, relative dating. What's that about, and why is it still so important if we have these absolute methods?
Right, relative dating doesn't give us a specific year like 400,000 BCE. What it does is determine the sequential order of events, basically what came before what. It establishes the timeline relative to other things at the site. And the absolute cornerstone of relative dating is stratigraphy. That's the study of the layers, or strata, of soil and cultural debris that build up over time. The basic principle is the law of superposition. In an undisturbed sequence of layers, the lower layers are older than the upper layers. It sounds simple, but it's fundamental.
So the stuff at the bottom got buried first. Makes sense.
Generally, yes. But you have to be careful. There are situations where the sequence can get mixed up. For example, in river valleys, you can sometimes get what's called reverse succession in terrace stratigraphy due to complex cycles of erosion and redeposition. So context is everything.
Gotcha. But stratigraphy gives us that crucial sequence, right? It stops us from, say, accidentally mixing up stone tools from two totally different millennia found at the same site.
Exactly, it provides the framework. Another relative method, more specialized, is fluorine dating. This works specifically on bones and teeth buried in the ground. See, bones and teeth gradually absorb fluorine from the groundwater over time. So if you compare two bones from the exact same site, the one with a higher percentage of fluorine has likely been buried longer and is therefore relatively older.
But only compared to other things at that specific site.
Yes, absolutely critical. Fluorine levels in groundwater vary wildly from place to place, so you can't compare fluorine dates between different sites. It's strictly site-specific. And what's really important to stress here is the rigor involved, because every dating technique has its limitations, potential sources of error, or contamination issues. Professional archaeologists almost always try to use at least two different independent dating methods on a site. That way you can cross-check the results and be much more confident that the chronological sequence you've established is robust.
That makes total sense. Build-in redundancy. Okay, so that robust methodology is our ticket into what you call the Stone Age trilogy. These huge epochs defined pretty much entirely by their material culture, their tools. We have to start at the beginning, the really deep beginning, the lower Paleolithic. We're talking a vast timescale here, stretching from maybe 2.5 million years ago right up to about 100,000 BCE.
Yeah, this period basically covers the cultural debris left behind during the entire Pleistocene epoch. And the Pleistocene, well, it was a time of intense global climate swings, massive climate volatility. Up north, in the higher latitudes, the Pleistocene saw at least 4 major phases of glaciation, huge ice ages. And those massive shifts in the north correspond with periods of very heavy rainfall, what we call pluvial periods, down here in peninsular India. And this non-uniform climate across the subcontinent is absolutely key to understanding the regional differences we see in the archaeology.
And the technology, the actual tools from this immense period. Pretty primitive stuff initially, right? Mostly using the direct hammer technique, just bashing one rock against another on whatever material was easily available, like quartzite.
That's right. Quartzite was the go-to material. And we tend to categorize the material culture here into two main industries, which show a kind of gradual evolution and sophistication over hundreds of thousands of years. First, you have the older tradition, sometimes called Abavillian or just the chopper chopping tool tradition. These are large, pretty crude tools. Think heavy choppers, chopping tools, and very basic, chunky hand axes. Powerful, maybe, but definitely lacking finesse.
Okay, big and basic, but then things start to get a bit more refined with the Acheulean industry.
Indeed. The Acheulean stage becomes the dominant global industry during the later Lower Paleolithic. And it's characterized by tools that are much more standardized. They're often smaller, typically pear-shaped or oval hand axes, and also cleavers tools with a straight cutting edge. And critically, as Acheulean techniques improved, you see a definite decline in the frequency of those older, cruder chopper-chopping tools. People were clearly getting better at producing effective bifaces tools, worked on both sides.
Right, bifaces. And this is where that regional variation within India becomes really critical, isn't it? We can't just talk about one single lower Paleolithic culture across the whole place.
Absolutely not, because the climate zones were so different, the adaptations were different. If you look north, for instance, focusing on the Soan Valley, which is in modern-day Pakistan, you find what's called the Soan culture. This dates roughly from 500,000 to 125,000 BCE. Excavations there revealed a sequence of 6 distinct river terraces showing occupation over a long time, and the toolkit found there, overwhelmingly dominated by those heavy, robust chopper-chopping tools we mentioned earlier.
Okay, so the Soan in the north is chopper heavy, but then if you travel south, down into peninsular India, you find a completely different technological signature, the Madrasian culture.
Yeah, the Madrasian is really renowned for its sophistication, especially compared to the Soan. It features beautifully made, highly refined hand axes and cleavers. These were often prepared using what archaeologists call the Vaal technique, which is a specific method for thinning the biface to create a really standardized, sharp, symmetrical edge. This wasn't just bashing rocks. It required real foresight, planning, and skill.
That level of skill leads us to something really intriguing, a claim made by the legendary Indian archaeologist H.D. Sankalia. He suggested he found evidence of hafting on Madrasian tools. Hafting meaning like attaching the stone tool to a handle.
Exactly. Attaching a stone point or axe head to a wooden or bone handle or shaft. Now, if Sankalia's claim could be conclusively proven for that early, lower Paleolithic time frame, honestly, it would be a global game changer. Think about what hafting requires cognitively. You have to select the right materials for the handle, figure out how to attach it securely, maybe using adhesives like bitumen or plant resins or bindings. You need to understand balance and leverage. You have to mentally construct a composite tool that doesn't physically exist yet. Finding that kind of complex planning so early in the Indian context would put the cognitive abilities of these early humans right up there with, or possibly even ahead of, what we see in other regions often considered centers of early innovation. It really underscores the potential sophistication within the Acheulean here.
That's fascinating. And we have sites that show this incredible depth of time, right? Like Didwana in Rajasthan, and of course the huge rock shelter complex at Bhimbetka in Madhya Pradesh.
Bhimbetka is phenomenal. Specifically, Cave 3rd F23 there yielded this amazing sequence, 8 distinct cultural formations, all stratified one on top of the other. And right down at the very bottom, the foundational level, lower Paleolithic Acheulean tools. It's like a layer cake of prehistory.
Wow. Okay, so this technological evolution doesn't just stop there, it progresses, taking us into the next major phase, the Middle Paleolithic. This spans roughly 100,000 BCE down to about 36,000 BCE.
Correct. And the defining characteristic of this era is another profound shift, both in the technology and in the preferred raw materials. We see a move away from those large, bulky quartzite tools that dominated the lower Paleolithic.
People started looking for better quality stone.
Absolutely. The preferred material now shifts to much finer-grained, high-quality cryptocrystalline silica. Think materials like quartz, flint, chert, jasper, chalcedony. These types of stone fracture much more predictably when struck. They give you much greater control over the shape and sharpness of the final tool.
And what was the result of upgrading the raw material like that? What did the tools look like?
The tools themselves changed quite dramatically. Instead of large core tools like hand axes, flake tools become totally dominant. These are tools made from the flakes struck off a core rather than the core itself. So you see lots of scrapers, points, borers, smaller, lighter, often more specialized tools. The manufacturing technique also shifts. People are using pecking and direct hammer methods, but specifically aimed at producing these standardized flakes from carefully prepared cores. The industry found at Navasa, for instance, in Maharashtra, heavily features flakes made using the Levallois technique.
Ah, the Levallois technique. That's often seen as a key marker in Europe and Africa too, isn't it? Does finding it here imply some kind of direct cultural connection, or is it more likely parallel innovation?
That's the million-dollar question. It most likely suggests parallel innovation. Humans in different parts of the world, facing similar needs for efficient, sharp, standardized cutting edges, independently converged on this very clever prepared core technique. So the Navasa industry, technologically, looks very similar to the Mousterian culture found in Europe, which is associated with Neanderthals there. It shows a similar level of cognitive planning and skill. However, even within the Middle Paleolithic, that regional variation we saw earlier is still crucial. Sites like Luni in Rajasthan, for example, show a wider variety and perhaps different types of tools compared to Navasa. This probably reflects adaptation to unique local environments, different available raw materials, or maybe specialized hunting needs across the major river valleys like the Godavari, Sun, and Krishna.
But the basic economy, the way people live day to day, that was still pretty much rooted in hunting and gathering, right?
Oh yes, absolutely. Sustenance is still based entirely on foraging from the immediate environment. But you could argue that the efficiency of hunting and processing resources was likely increasing with these lighter, sharper, more diverse flake tools compared to the heavier lower Paleolithic kit.
Okay, so increasing efficiency. And that efficiency seems to hit a new peak in the next period, the Upper Paleolithic, which runs from about 36,000 BCE down to around 9,000 BCE. This period coincides with the final, really intense phases of the last Ice Age glaciation and the corresponding pluvial periods further south.
Right, and the material culture, the technology of the Upper Paleolithic, is really characterized by the dominance of blade technology.
Blade technology, what does that mean exactly?
It means the primary goal of stone tool production shifted to creating long, narrow, parallel-sided flakes called blades. These were struck from carefully prepared cylindrical cores, often using an indirect percussion technique like using a punch, which gives even greater control. Think of it as a way to mass-produce highly effective, standardized cutting edges from a single core. These blades could then be used as knives themselves, or modified into various specialized tools like burins for engraving or end scrapers. It's a very efficient use of raw material.
And are we still talking mostly about cryptocrystalline silica, or do we see other materials coming into play?
Quartz and similar materials are still important, but significantly, we see bone becoming a common and crucial raw material for tools during the Upper Paleolithic. The discovery of well-made bone tools, things like harpoons, spear points, needles, awls, maybe even decorated items at sites like Muchchatla Chintamani Gavi in Andhra Pradesh, is a major hallmark of this period. Using bone suggests a focus on more specialized hunting, perhaps fishing or hunting larger game where bone points were needed. It also shows a greater investment in creating durable, task-specific instruments that took more effort to make than simple stone flakes.
That's a big step. But perhaps the truly transformative aspect of the Upper Paleolithic isn't just about tool efficiency or new materials. It seems to be the period where we see the beginnings of much clearer, more symbolic social development. The evidence for things like rites and rituals seems to appear more frequently.
Absolutely.
Yeah.
This period, although shorter than the previous ones, seems to have been a time of quite rapid cultural development. We see evidence suggesting significant advancements in social organization, maybe larger group sizes, more complex hunting strategies. But the most stunning development, the one that truly sets the Upper Paleolithic apart and connects these ancient people directly to us, is the emergence of art. The earliest conclusive evidence of rock art in India comes from this period.
Wow. The first tangible signs of creative expression, of symbolism. Where do we find this early art, and what does it actually show?
Key sites, like, again, Bhimbetka, but also places like Lakudiyar in Uttarakhand, provide this initial artistic record.
Yeah.
The paintings were made using natural mineral pigments, ochre providing reds, yellows, and browns, maybe manganese or charcoal for black, kaolin for white. These were ground up and likely mixed with water or animal fat, then applied to the rock shelter walls. What did they depict? Well, humans, often in dynamic hunting scenes or dancing, lots of animals, bison, elephants, tigers, rhinos, deer, the megafauna of the time, and also intriguing geometric patterns, lines, dots, shapes, whose meaning is lost to us. This art marks a fundamental moment. It's the moment when early Homo sapiens in India began to externalize their thoughts, their beliefs, their observations of the world around them onto a permanent medium. It's a profound cognitive leap, a window into their minds.
That is incredible. A monumental creative step. And it feels like that step, that growing complexity, really set the stage for the next big transition, the move away from a purely nomadic hunting-gathering lifestyle. Which brings us neatly into Section 3, the transition. Here we're covering the Mesolithic period and that momentous shift that V.G. Child famously called the Neolithic Revolution.
Exactly. The Mesolithic culture, which spans roughly 9,000 BCE down to about 4,000 BCE in India, really acts as the crucial bridge between the Paleolithic hunter-gatherers and the Neolithic farmers. And it's defined, first and foremost, by another massive environmental shift. The end of the last ice age.
Right. The climate warmed up dramatically, didn't it?
Dramatically and relatively quickly. Glacial conditions retreated globally, giving way to a generally warmer, wetter climate, more like the conditions we see today, though still variable. This had huge ecological consequences. Melting ice opened up vast areas of land, forests probably became denser in many regions, river systems changed, coastlines shifted, and crucially, animal populations changed too. Maybe large Ice Age megafauna declined, while smaller, faster animals like deer and gazelle thrived. And think about it. Those heavy, bulky Paleolithic hand axes and choppers, they would have been pretty disadvantageous for hunting smaller, quicker prey in denser forests.
Makes sense. You need something lighter, faster. Which leads directly, I assume, to the defining technological feature of the Mesolithic, the microliths.
Precisely. Microliths, literally meaning small stones, are the absolute signature technology of this period. These are tiny, geometrically shaped, chipped stone pieces, often just a centimeter or two long. They were meticulously prepared, often using a technique called pressure flaking, or the fluting technique to remove tiny bladelets from a core. You find triangles, lunates, crescent shapes, trapezes, and crucially, these tiny pieces were almost never used individually. Their real genius lies in their function as components of composite tools.
Composite tools, meaning they were like stuck onto handles or shafts.
Exactly. They were hafted onto wood, bone, or antler handles or shafts using adhesives like birch bark tar or plant resins. You could set several microliths in a row to create a sharp cutting edge for a knife or a sickle. Or you could mount a single geometric microlith as a sharp penetrating barb or tip for an arrow or a harpoon. This dramatically increased the efficiency and success rate of hunting, fishing, and maybe even early plant gathering. And that increased efficiency, in turn, could support slightly larger, perhaps slightly less mobile social groups than in the Paleolithic.
Okay, so the Mesolithic isn't just about tiny tools. It really represents this critical transitional phase where Homo sapiens were actively adapting to a changing world, moving towards a more settled and productive economy, even if they weren't full-blown farmers yet. And we have some incredible archaeological sites that give us insights into this shift, don't we?
We do. The site of Sarai Naharai in Uttar Pradesh, dated way back to around 8000 BCE, gives us some of the oldest Mesolithic evidence in India. Excavations there found structured living floors suggesting repeated occupation with organized fire hearths. And significantly, we start seeing more formalized evidence of ritual behavior, particularly human burials, where bodies were placed in specific postures, sometimes with grave goods. They also found bones of animals that might represent early stages of domestication alongside wild species.
But there was one detail from Sarai Naharai that really shocked researchers when it was found, wasn't there? Evidence of violence.
Yes. The discovery of 13 human skeletons, some buried together, and crucially, one skeleton where a microlith point was found embedded in or near the rib cage. This provides pretty clear evidence for intergroup conflict, maybe even warfare. It suggests that as Mesolithic groups perhaps became slightly more settled, more territorial, or started managing resources more intensively, the potential for conflict over those resources or territories increased. Life wasn't necessarily peaceful.
A sobering thought. Now, if we contrast that early site with Langnaj in Gujarat, which dates a bit later, maybe 2400 down to 2000 BCE, what does Langnaj tell us about the path towards settlement?
Langnaj is really interesting. It shows strong evidence for early degrees of pastoralism managing animals. They found skeletons of both wild animals and domesticated species like cattle, sheep, and goat, alongside human skeletons which were again buried in specific, flexed or crouching postures, suggesting continued ritual practices. But what makes Langnaj particularly perplexing and important is its chronological overlap and potential material connections with the later, fully urban Harappan civilization. Some researchers suggest there might have been trade links, perhaps Mesolithic groups at Langnaj supplying forest produce or other goods to the nearby Harappan port city of Lothal in exchange for cereals or other items. This hints that Mesolithic groups weren't necessarily isolated. Some are likely being drawn into the orbit of larger, emerging economic systems, which probably accelerated the transition.
That makes perfect sense. That interaction likely fueled the shift into what we call the Neolithic culture, spanning a broad period from maybe 7,000 down to 1500 BCE in different parts of India. This is the period that the famous archaeologist V.G. Child termed the Neolithic Revolution.
Right. Child saw the Neolithic as this sudden, dramatic, and truly revolutionary socioeconomic package deal. He emphasized the rapid shift to a sedentary lifestyle based on agriculture, the large-scale domestication of plants and animals, the invention of pottery, and the resulting emergence of villages and potentially more complex political organization needed to manage food surplus and settled life.
It sounds revolutionary, but there's been a critique of that term revolution in more recent anthropology, hasn't there? Why the pushback?
Well, the critique isn't necessarily that the outcome wasn't revolutionary, because permanent settlements and agriculture fundamentally changed human society forever. The critique is more about the process. Many anthropologists argue that the Neolithic shouldn't be seen as a sudden invention that burst onto the scene. Instead, it was more of a culmination or perhaps an acceleration of gradual changes that had already been developing throughout the Mesolithic. Things like increasingly specialized toolkits, maybe early experiments with managing plants or animals like we saw hints of at Langnaj, a slow shift in raw material preferences away from just stone. These trends were already underway. The Neolithic is when they all came together and intensified, leading to that truly sedentary food-producing lifestyle.
Okay, so maybe not an overnight revolution, but definitely a revolutionary outcome. And the material culture, the artifacts of the Neolithic, clearly reflect this new commitment to permanent agriculture and settlement, right? We move beyond just chipping stone flakes.
Absolutely. The defining stone tool technology of the Neolithic is grinding and polishing. Instead of just chipping, people started grinding stone tools against an abrasive rock, like sandstone, often using water, to create incredibly smooth, durable, and precisely shaped tools. The classic Neolithic tool types are celts, things like axes and adzes. These were often made from tough, compact stones, polished smooth, and then securely attached or hafted to strong wooden handles. And these polished stone axes were absolutely essential tools for the large-scale task of clearing forests to create fields for agriculture.
Makes sense. You need heavy-duty tools for that. And if you're growing crops and settling down, you suddenly have a new problem. How do you store the food surplus? Which presumably leads to the development of pottery.
Pottery is absolutely essential to the Neolithic package. If you're harvesting grain, you need containers to store it safely away from pests and moisture, and also vessels for cooking porridges or stews. Initially, the pottery tends to be quite basic, often handmade, maybe coiled or built up from slabs and fired at relatively low temperatures, making it quite coarse and fragile. We call this ill-fired. But as the Neolithic progresses, particularly towards the end of the period, we start to see the development of wheel-made pottery. Using a potter's wheel allows for much faster production, more uniform shapes, and often leads to better firing techniques in more sophisticated kilns, resulting in harder, more durable pottery suitable for long-term storage.
Okay. Now, just like in the Paleolithic and Mesolithic, when we look at the Neolithic across the vastness of India, we again see significant regional variations, right? Based on local climate, available crops, different cultural trajectories.
Definitely. One of the most important Neolithic sites, not just in India, but in all of South Asia, is Mehrgarh, located on the Kachi Plain in modern-day Pakistan. It dates back incredibly early, perhaps as far as 7000 BCE. Mehrgarh is crucial because it provides our oldest and most complete evidence for the development of farming and herding in the region. Excavations there show this clear, gradual evolution over millennia. Period I, at Mehrgarh, from about 7000 to 5500 BCE, is fascinating because it's known as the Aceramic Neolithic. This means people were living in permanent mud brick houses, cultivating crops like wheat and barley, and herding animals. But they did it without using pottery yet.
Wow, farming before pots. That's counterintuitive.
It shows that the different elements of the Neolithic package didn't necessarily all arrive at the same time everywhere. Pottery seems to appear later at Mehrgarh, in period 2, which transitions into the Neolithic-Chalcolithic phase, where early copper tools also start showing up. Mehrgarh really is the gold standard for tracking that whole process in South Asia.
Okay, Mehrgarh is cute. Then you have really unique regional adaptations like up in Kashmir at Burzahom.
Burzahom is different again. Located in the Kashmir Valley, it experienced a much colder, drier climate. The people there developed very distinctive pit dwellings. They dug circular or oval pits into the soft, loess soil, sometimes quite deep, maybe roofed them with timber and thatch, likely for better insulation against the cold. Their material culture initially includes handmade coarse gray pottery. But what's interesting at Burzahom is that in later periods, maybe overlapping with the Neolithic or slightly after, we see the appearance of large memorial stones called menhirs and also early copper objects. This suggests connections or transitions into the later megalithic and copper-using traditions of the region.
And finally, what about the fertile Gangetic Plain in areas like Uttar Pradesh and Bihar? What did Neolithic life look like there?
In the Gangetic Plain, Neolithic settlements tended to cluster near the rivers and floodplains, taking advantage of the rich alluvial soils. People lived in sedentary villages, likely in wattle and daub huts. The key crop here seems to have been rice. We find evidence like charred rice grains and impressions of rice husks in pottery. Alongside farming, they clearly continued the established traditions of hunting and fishing, exploiting the rich riverine resources. So you see this pattern. Across these different regions, people settled down, developed agriculture based on locally suitable crops, created pottery, and built the stable economic foundation, the agricultural surplus that was necessary for the next great technological and social leap, the introduction and mastery of metal.
Which takes us right into Section 4, the Metal Ages. Here we're going to watch how cultures moved from those first tentative experiments with copper through to the unprecedented urbanism of the Bronze Age, and ultimately explore the theories behind its mysterious collapse.
We start with the Chalcolithic culture. The name itself, Chalcolithic, kind of gives it away, right? Copper Stone Age, roughly 4,500 down to maybe 1000 BCE in India. Exactly. This is the era defined by the technological coexistence of copper and stone tools. It marks the first widespread, systematic use of metal technology in the subcontinent, specifically copper. People learned the skills of smelting copper, or extracting the metal through heat and then casting or hammering it to manufacture utilitarian tools and weapons. Things like copper arrowheads, axes, chisels, beads, bangles. But importantly, they also continued to make and use sophisticated stone tools, particularly long stone blades made from fine-grained silicas, often alongside the copper ones.
So it wasn't an immediate replacement of stone by metal.
Not at all. They use both technologies, choosing the best material for the task. But this introduction of metalworking, even alongside stone, seems to have supported a new level of social organization. During the Chalcolithic, we really see the emergence of full-fledged permanent villages across many parts of India. The economy becomes heavily centered around sustained agriculture, cultivating crops like barley, wheat, lentils, rice depending on the region, and organized animal husbandry, particularly cattle. And this permanence, this investment in land and villages, seems to lead to the formalization of other aspects of life, including belief systems. We start to see clearer evidence for rudimentary religious practices. Finds include terracotta figurines, often interpreted as mother goddesses, suggesting fertility cults. We see evidence for the veneration of bulls, maybe linked to agricultural strength, and specific burial customs, with bodies often placed in particular orientations and sometimes accompanied by blots or tools as grave goods, point to a developing belief in an afterlife.
Now, the Chalcolithic can be a bit tricky to get a handle on because, unlike the later Indus Valley civilization, which was remarkably uniform, the Chalcolithic seems to have been extremely diverse across India, right? The sources often talk about distinct cultural zones, mainly defined by their pottery styles.
That's a key point. The Chalcolithic was definitely a mosaic, not a monolith. It wasn't one single culture, but rather a collection of regional cultures sharing the basic technology of copper and stone tools, farming, and village life, but expressing their identity through distinct local traditions, especially their pottery. Our sources typically divide Chalcolithic India into about 5 or 6 major cultural or ceramic zones, each with its own characteristic pottery industry.
Okay, let's quickly run through those main zones. What do they tell us?
Well, starting in the northwest, in Rajasthan, you have the Aharbanas culture, roughly 2600–1500 BCE. Their hallmark pottery is a distinctive black and red ware, BRW, often with geometric patterns painted in white on the exterior. Ahar itself was a significant copper smelting site. Moving east and south into Madhya Pradesh, you encountered the widespread Malwa culture around 2100 BCE. This is known for its quite robust, thick, brown slip pottery, often painted with elaborate designs in black or dark brown. Sites like Navdatoli are key here.
Then there's the Gangetic Doab region between the Ganges and Yamuna rivers. This area is particularly intriguing because it's associated with the mysterious copper hoard culture.
Correct. The copper hoards themselves are these caches of unusual copper objects, things like anthropomorphic figures, harpoons, and tennis swords, often found buried together, seemingly without associated settlements. Their exact function is debated, maybe ritual deposits. These hoards are often found in association with a type of pottery called ochre-colored pottery, OCP. OCP typically has a distinctive orange to ochre color and often feels powdery or washed out, maybe due to weathering or poor firing. The relationship between the hoards and OCP settlements, dating perhaps 2500 and 1350 BCE, is still being worked out, but it marks a major regional identity in the north.
Okay, moving further south into the Deccan Plateau.
In the northern Deccan, particularly Maharashtra, we find the important Jorwe culture, flourishing maybe 1400, 1300 BCE, though starting earlier. Jorwe pottery is very distinctive. It's usually a fine fabric with a red or orange matte surface painted with elegant geometric designs in black. They had large settlements like Daimabad and Inamgam, showing complex village planning. And finally, further south, we have the southern Chalcolithic group, broadly 2400 to 1000 BCE, covering parts of Karnataka and Andhra Pradesh. Sites like Tikalakote, Brahmagiri, and Saganakalu belong here. These southern sites share similarities with the Deccan cultures, but also have unique features. One of the most striking and puzzling is the presence of huge ash mounds.
Ash mounds, right. These are literally massive heaps of burnt cow dung. They sound mundane, but you're saying they're actually really significant for understanding Chalcolithic life in the south.
Absolutely. They're far more than just ancient garbage dumps. Some of these mounds are enormous, several meters high, covering large areas. They represent the accumulation and deliberate, repeated burning of vast quantities of cattle dung over long periods. Archaeologists, often drawing on ethnoarchaeology studying modern pastoral groups, interpret these ash mounds as ritual sites. The thinking is they might have been locations for seasonal cattle camps or corrals. Perhaps vast amounts of dung accumulated during the dry season were burned ritualistically, maybe as part of a purification ceremony, a festival linked to fertility, or before a seasonal migration with the herds. Whatever the exact reason, these ash mounds point to a society where cattle were hugely important, not just economically but also ritually. They indicate that even these supposedly settled Chalcolithic farming communities likely maintained a strong element of mobile pastoralism, centered around the veneration and management of cattle. It's a unique feature of the Southern Chalcolithic.
That's fascinating. A ritual landscape built from dung. Okay, so this established base in copperworking, stone tools, farming villages, and regional diversity, it leads directly into the next truly extraordinary phase. The Bronze Age and the rise of the Indus Valley Civilization, IDC, flourishing roughly between 3300 and 1300 BCE, with its mature urban phase around 2600-1900 BCE. The key technological shift here is bronze, right?
Yes, bronze becomes the dominant metal, although copper and stone tools certainly continued to be used. Bronze is an alloy, typically made by smelting copper with a small amount of tin or sometimes arsenic. And bronze is significantly superior to pure copper for many applications. It's harder, it's more durable, it holds a sharp edge much better, and it's easier to cast into complex shapes. This technological upgrade, combined with the already established agricultural stability from the preceding Chalcolithic and early Harappan phases, really seems to have enabled the unprecedented level of social organization and urbanism we see in the mature IVC.
And that urbanism is what truly distinguishes the IVC. This remarkable, almost mind-bogglingly standardized system of town planning that we see across all its major sites, Harappa, Mohenjo-daro, Dhalavira, Ganridiwala, Rakhigarhi. What does this incredible uniformity tell us about how their society was governed?
The standardization is stunning. You see it in the layout of the cities, the construction materials, even the weights and measures. It strongly implies a powerful, centralized authority, or at least a widely accepted system of shared norms and governance that was capable of planning, coordinating, and enforcing strict regulations across a truly massive geographic area, much larger than contemporary Egypt or Mesopotamia. The typical city layout involved a division into two main sections. Usually there was a raised, fortified area called the citadel, typically located to the west. This housed major public buildings, massive granaries for storing surplus grain, large assembly halls, administrative buildings, and often unique structures like the Great Bath at Mohenjo-daro. Then to the east, you had the lower town, which was the main residential area for the general population, laid out on a grid plan with streets intersecting at right angles.
And the construction itself was advanced.
Very much so. They used baked mud bricks, which are much more durable than sun-dried bricks, especially in areas with rainfall. And these bricks were remarkably standardized in their size ratio, usually 1.2.4 thickness.width.length, across the entire civilization. They also had incredibly sophisticated drainage systems, with covered drains running along the streets, connected to individual houses. This level of sanitation is unparalleled in the ancient world at that time.
That Great Bath at Mohenjo-daro, it really is a spectacular piece of engineering, isn't it?
It's astonishing. It's essentially the earliest known public water tank in the ancient world. About 12 meters long, 7 meters wide, and 2.4 meters deep. Okay. Constructed with finely fitted baked bricks, sealed with natural bitumen or tar to make it watertight. It had steps leading down into it from two sides. Its existence suggests not just advanced engineering capability, but also likely a formalized religious life centered around public ritual activity, almost certainly involving water for purification or ceremonial bathing.
And you mentioned Dhalavira earlier. That site offered a unique twist on the standard city plan.
Dhalavira, located out on an island in the Rann of Kutch in Gujarat, is fascinating. It stands out because its layout seems to be divided into three distinct parts: the citadel, a middle town, and a lower town, unlike the usual two-part division. It also features incredibly elaborate water management systems with large reservoirs and channels designed to capture and conserve scarce monsoon rainwater. And perhaps most famously, Dhalavira yielded that large signboard with 10 unique pictographic inscriptions, one of the longest-known sequences of Indus script signs found near a major gateway. Its exact meaning is unknown, but it hints at a complex system of communication and symbolic representation used in the public sphere, maybe for identifying districts, rulers, or gods.
This incredible urban complexity must have been fueled by a pretty robust economy. What was the basis of their wealth?
Absolutely. The foundation was extensive agriculture. They cultivated a variety of crops. Wheat and barley were staples, especially in the core regions, but also peas, sesame, mustard, dates, and importantly, cotton. The Indus people were likely the first in the world to cultivate cotton for textiles. Evidence for rice cultivation comes mainly from sites like Lothal and Gujarat, suggesting it might have been more important in coastal regions. Beyond agriculture, they had widespread craft specialization, pottery, bead making, especially from carnelian, shell working, metalworking, and crucially, they engaged in extensive long-distance trade, both overland and maritime. We have clear evidence of trade links with Mesopotamia, modern Iraq, Persia, Iran, and the Arabian Gulf region. They exported goods like timber, cotton textiles, carnelian beads, ivory, copper, maybe even exotic animals. In return, they likely imported raw materials like tin, silver, gold, and certain types of stone.
And the mechanism for managing all this trade, for identifying goods or traders, seems to have been those iconic Harappan seals, right?
The seals are absolutely central to understanding the IVC economy and administration. Thousands have been found. They're typically small, square, or rectangular, usually made of steatite, soapstone, and intricately carved with images, often animals like the unicorn, bull, elephant, rhino, and accompanied by short inscriptions in the still undeciphered Indus script. These seals were likely used like stamps, pressed into clay tags attached to bundles of goods, perhaps to indicate ownership, origin, or official approval. They were integral to the administration of trade and possibly taxation. In terms of their spiritual life, beyond the Great Bath, the recovery of countless small terracotta female figurines from many sites, often quite stylized, is usually interpreted as evidence for a strong, well-established cult focused on female fertility, a kind of mother-goddess worship.
And complementing that focus on female fertility, there's that really powerful image found on the so-called Pashupati seal.
Yes, the Pashupati seal, found at Mohenjo-daro, is one of the most famous and debated artifacts. It depicts a seated male figure, possibly with three faces, wearing a horned headdress, sitting in a yogic posture, perhaps a Padmasana. He's surrounded by four animals, an elephant, a tiger, a rhinoceros, and a buffalo, with two deer beneath his seat. This image strongly suggests the worship of a prominent male deity, perhaps associated with animals, fertility, asceticism, or shamanism. Many scholars see this figure as a potential prototype or early form of the later Hindu god Shiva, in his aspect as Pashupati, the lord of beasts. It points to a complex religious life involving both male and female deities and a deep connection with the animal world. Evidence for fertility cults also includes finds of phallic-shaped stones, lingams, and ring stones, yonis.
So we have this incredibly sophisticated, widespread urban civilization with complex trade, administration, and religious beliefs. But its success wasn't permanent. Around 1900 BCE, give or take, the major urban centers seemed to go into decline and were gradually abandoned. This brings us to one of the most contentious and debated topics in South Asian archaeology, the theories surrounding the decline of the Indus Valley civilization. How did this great urban experiment end?
You're right, this requires careful and impartial reporting, because honestly, despite decades of intensive research and numerous theories, there is still no single universally accepted explanation for the decline of the IVC's urban phase. It was likely a complex process with multiple contributing factors playing out differently in different regions. Early in the 20th century, when the civilization was first being excavated, the dominant theory, championed by archaeologists like Sir Mortimer Wheeler, R.D. Banerjee, Stuart Piggott, and D.H. Gordon, was the foreign invasion theory.
The idea that invaders swept in and destroyed the cities?
Essentially, yes. This theory proposed that the Indus cities were weakened or destroyed by incoming groups of nomadic warriors, often identified with the Indo-Aryan speakers mentioned in the later Vedic texts, particularly the Rig Veda, which contains hymns referring to battles and the destruction of forts, puras. Wheeler famously pointed to skeletal remains found scattered in the upper layers of Mohenjo-daro as evidence of a final massacre.
Okay, that sounds dramatic, but this invasion theory has faced some serious, sustained criticism over the years, hasn't it? Why is it now largely, discarded by most of the academic community?
There are several major problems with it. Firstly, the skeletal evidence at Mohenjo-daro is very flimsy. The remains are few, not all show signs of violence, and they weren't all found in contexts that clearly indicate a single massacre event. Some might represent hasty burials or unburied dead during a period of social breakdown. Secondly, the chronology doesn't really match up well. The decline of the Indus cities seems to begin well before the dates generally ascribed to the arrival of Indo-Aryan speakers based on linguistic and later archaeological evidence. And perhaps most importantly, the overall archaeological record across the major Indus sites simply lacks widespread evidence of destruction layers. No mass burnings, no signs of organized siege warfare that you would expect to find if a massive, violent invasion had occurred. The decline appears to have been more gradual, systemic, and complex than a sudden conquest.
Okay, so if invasion isn't the likely culprit, what are the leading alternative theories? Many seem to focus on environmental factors.
Yes, environmental stress theories have gained much more traction and seem to be supported by better evidence. One major category is the climate change theory. Paleoclimate research suggests that around the beginning of the second millennium BCE, there might have been a significant shift towards increased aridity across northwest India and Pakistan. This could have led to weaker monsoons, prolonged droughts, and ultimately the failure of the sophisticated agro-pastoral economy that sustained the large urban populations. A decline in food surplus would have undermined the centralized authority and led to social instability and population dispersal.
And closely related to climate change are theories involving changes to the river systems, which were the lifeblood of the civilization.
Absolutely. We have the tectonic phenomena theory, which suggests that major earthquakes the region is seismically active might have caused widespread disruption. Earthquakes could have directly destroyed settlements, caused devastating floods by damming rivers, or, crucially, altered the courses of major rivers. This ties into the very influential hydrological changes theory. This focuses specifically on the potential drying up or shifting course of the Ghaggar-Hakra river system, which flowed parallel to the Indus through a large part of the civilization's territory. Many large Harappan sites are located along its ancient banks. Many scholars identify the Ghaggar-Hakra with the mystical Saraswati River, mentioned in the Rig Veda. If this river system significantly diminished or shifted its course, perhaps due to tectonic uplift in its Himalayan headwaters, or captured by the Yamuna River system, it would have rendered vast tracts of fertile agricultural land useless, leading to ecological disaster, famine, and mass migration away from the affected urban centers.
So it sounds like the most likely scenario involves a combination of these environmental factors, maybe climate change weakening the system, and then river shifts delivering the final blow in certain key areas.
That seems to be the emerging consensus. A complex interplay of factors, climate change impacting agriculture, tectonic activity altering landscapes and river flows, perhaps leading to resource scarcity, internal social stress, breakdown of trade networks, and maybe even outbreaks of disease in overcrowded cities. The highly standardized, perhaps somewhat rigid system that allowed the IVC to flourish might have also made it vulnerable when faced with unprecedented, large-scale environmental changes it couldn't adapt to quickly enough. We should probably also mention, just for completeness, some more fringe ideas, like the Russian scholar Dmitriev's black lightning theory. This speculates about drastic physiochemical changes in the atmosphere, perhaps a sudden temperature rise or the release of toxic agents, causing catastrophic destruction. But this lacks significant supporting evidence compared to the climate and river theories. Regardless of the exact causes, the result was clear. The great urban centers were gradually abandoned around 1900 BCE. The population dispersed, and the unified IVC culture fragmented into various regional, mostly rural cultures, known collectively as the post-Harappan or late Harappan period. The era of grand urbanism was over for many centuries.
A fascinating, complex puzzle. Okay, so from the decline and fragmentation of the Bronze Age IVC, we transition into our fifth section. The Iron Age and megalithic culture in India, spanning roughly 1500 down to about 500 BCE.
This era is fundamentally defined by the widespread adoption and successful mastery of a new metal technology, iron, or ferrous metallurgy. Iron smelting and working eventually superseded bronze and copper across most of the subcontinent. Now, initially, early iron might not have been inherently harder or better than good quality bronze, but the key advantage of iron was the sheer abundance and accessibility of iron ore compared to the relatively rarer ores of copper, and especially tin needed for bronze. Iron was available almost everywhere.
And having readily available iron tools, things like axes, sickles, plowshares, hoes, as well as weapons like arrowheads and spearheads, must have had a massive societal impact, particularly in areas like the northern plains.
It was absolutely transformative, especially for agriculture and settlement patterns. Strong, affordable iron axes allowed for the large-scale clearance of the dense, monsoon forests of the Gangetic Plain, something much harder to do with softer copper bronze or stone axes. This opened up vast new areas for farming. Iron plowshares allowed for deeper tilling of heavier soils. This technological shift enabled a huge expansion of agricultural land, supported larger populations, and facilitated the establishment of permanent village settlements that eventually grew into the towns and kingdoms of the historical period. The Iron Age in India is often clearly divided into two broad geographical zones, a northern zone and a southern zone, each with distinct cultural markers, particularly pottery types and burial customs.
Okay, let's focus on the northern zone first. This area, particularly the Gangetic Valley and surrounding regions, is strongly associated with the painted grayware, PGW, culture, dating roughly from about 1200 BCE down to 600 BCE. We find PGW at major sites that later become famous in epics in history, like Hastinapur, Mathura, Ahichatra, Kasambi.
That's right. The pottery itself, the PGW, is quite distinctive and tells us something about the technological level. It's typically a very fine, smooth, well-levigated gray fabric. It's usually quite thin-walled and elegant. The uniform gray color indicates that it was fired at high temperatures in well-controlled kilns, with a reducing atmosphere meaning oxygen was restricted during firing. This represents a significant technological advancement over most earlier pottery traditions. The shapes are generally simple and utilitarian, mostly straight-sided bowls and dishes, sometimes small globular pots or lotus. And as the name suggests, it's often decorated with simple geometric patterns, dots, lines, circles, swastikas painted in black pigment before firing.
And socially, what does the PGW culture represent? Is this the beginning of cities again?
Not quite cities in the IVC sense yet. The PGW culture seems to represent primarily a village-based society, but one with increasing scale and complexity compared to the preceding Chalcolithic or late Harappan phases in the north. We see evidence for large-scale colonization of the Gangetic Plains, enabled by those iron tools for forest clearance. Settlements become larger and more permanent. There's evidence for specialized craft activities beyond pottery, like metalworking and beadmaking. Agriculture was central, with cultivation of rice, wheat, and barley, supplemented by animal husbandry, cattle, sheep, goat, pig, and hunting. Many scholars associate the PGW culture with the later Vedic period described in texts like the Brahmanas and Upanishads. It seems to represent the crucial phase of settlement and state formation, just before the emergence of the large Mahajanapadas, the first major kingdoms and urban centers of the historical period in North India, around the 6th century BCE. So PGW lays that foundation.
Okay, so PGW in the north is about agricultural expansion and laying the groundwork for future states. Simultaneously, down in the southern zone peninsular India, the Iron Age takes on a very different and visually spectacular character with the rise of the megalithic culture.
Yes, the megalithic culture is strongly associated with the Iron Age in South India, covering a similar time frame, roughly from 1500 BCE, or maybe even earlier at sites like Halur in Karnataka, which show very early iron, down to around 500 BCE or later in some areas. Key sites include Brahmagiri, Maski, Nagarjunakonda, Adichanallur, and Porkalam. The term megalithic comes from the Greek megas, large, and lithos, stone. And as Sir Mortimer Wheeler defined it, these were essentially monuments constructed of large, often undressed or roughly dressed, blocks of stone. These monuments were erected primarily to fulfill funerary or sometimes religious or commemorative functions. The scale is truly impressive. Researchers have identified something like 2,200 megalithic sites across South India, particularly concentrated in the states of Tamil Nadu, Kerala, Karnataka, Andhra Pradesh, Telangana, and also parts of Maharashtra.
Wow, thousands of sites. And what about the material culture found with these large stone monuments? Does it confirm the Iron Age connection?
Absolutely. Excavations of megalithic burials consistently yield locally manufactured iron implements. Common finds include iron axes, often socketed, sickles, hoes, chisels, tripods, lamps, and significantly, weapons like daggers, swords, spearheads, and arrowheads. This clearly places the megalithic builders firmly within the Iron Age technological sphere. The typical pottery found in these burials is also quite distinctive. It's usually the black and red ware, BRW. Similar in technique to the Chalcolithic BRW, but often with different shapes and sometimes a highly polished or burnished surface. You also find all black ware and sometimes russet-coated painted ware. But the most specific, perhaps most insightful detail for understanding the beliefs and practices of these people comes from the incredible variety of burial types associated with the megaliths. They weren't all built the same way.
Right. These different burial structures must speak volumes about the rituals surrounding death, maybe social status. Can we break down some of the key types?
We can. There's a lot of regional variation, but some common forms stand out. First, you have the cairn circle. This usually involves burying the deceased, sometimes in a pit, sometimes in a large pottery urn, and then erecting a circle of boulders or rubble around the grave, often topped with a heap cairn of smaller stones. It clearly demarcates the burial spot. Second, and often more elaborate, is the cist grave. Here, the burial, again, could be primary inhumation or secondary burial of bones collected after exposure, is placed within a box-like chamber, or cist, built below ground level using upright stone slabs, orthostats, for walls and capped with another large slab, capstone. Sometimes these cists were accessed via a porthole cut into one of the orthostats. They represent a significant investment of labor.
Okay, cairns and cists are mostly below ground or at ground level. What about the larger, more monumental freestanding structures?
Those are perhaps the most iconic. You have menhirs known locally in Tamil as nadukal. These are single, large, tall standing stones, sometimes several meters high, erected vertically. They usually serve as memorials or commemorative markers, often indicating the presence of a nearby grave, perhaps for a warrior or chieftain. And then you have dolmens, or dolmenoid cists. These are structures where the burial chamber is built above ground. Typically, the body or remains were placed on a floor slab, surrounded by several upright stone slabs, and then roofed over with a massive, often flat-topped capstone, creating a kind of stone table or house-like chamber. Access might be through a gap between the orthostats or a portal.
Building these dolmens and menhirs, moving and positioning those massive stones without modern machinery, that must have required significant communal effort, planning, and social organization, right?
Without a doubt. It implies not just technological skill, knowing how to quarry, transport, and erect these stones, but also a complex social structure capable of mobilizing and coordinating labor for these non-utilitarian ritual purposes. It suggests a strong collective belief system centered on ancestor veneration or beliefs about the afterlife. The evidence suggests these megalithic builders lived in permanent settlements, likely in huts made of perishable materials like wattle and daub, often located near their burial grounds. The widespread use of iron tools presumably provided the agricultural stability and perhaps the social stratification necessary to support these large-scale, labor-intensive ritual construction projects. They represent a distinct and powerful cultural tradition that dominated South India during the Iron Age.
It's amazing how diverse the Iron Age looks across India, PGW in the north, megaliths in the south. Okay, we've journeyed across these immense timescales, focusing on tools, climate, settlements, and cultures. But to really connect the dots, we need to bring the actual humans back into the picture more explicitly. Section 6 does this by looking at paleoanthropology, the fossil evidence for human origins in India, and ethnoarchaeology, which uses modern cultural parallels to understand the past.
Right. Starting with the really deep past, the oldest evidence we have for hominoids, the broader ape family that includes humans in the Indian subcontinent, comes from Civipithecus. The fossils date way back to the Miocene epoch, roughly between 14 and 8 million years ago.
And these Civipithecus fossils, mainly found in the Siwalik Hills, foothills of the Himalayas, caused quite a stir initially because they were misclassified, weren't they?
They were indeed quite famous for a while. Early discoveries, particularly jaw fragments, were initially associated with another fossil form called Ramapithecus, and because Ramapithecus had some features thought to be human-like, like a thicker tooth enamel and maybe a more parabolic dental arcade, though this was debated, both were considered potential direct ancestors to modern humans, placing a key stage of human evolution right there in South Asia. Civipithecus itself was characterized by things like a relatively small face compared to its brain size, a reduced snout compared to apes like chimpanzees, a U-shaped dental arcade, though maybe less so than chimps, and large incisor teeth. However, later discoveries of more complete fossils, including skulls, and more rigorous phylogenetic analysis in the late 1970s and 80s revealed key similarities between Civipithecus and modern orangutans, particularly in facial structure. The scientific consensus now is that Civipithecus is not on the direct human line, but is instead an ancestor or closely related to the ancestor of the orangutan genus Lupongo. It's a great example of how scientific understanding evolves as new evidence comes to light. The initial interpretation was exciting, but ultimately incorrect.
Okay, so Civipithecus is an ancient ape ancestor, but not our direct ancestor. If we shift from hominoids millions of years ago to actual early human skeletons, the tool users we've spent most of our time discussing, we come to the really monumental discovery of Narmadaman.
Narmadaman is truly a landmark find for Indian paleoanthropology. This was discovered by the geologist Dr. Arun Sanakia back in 1982 in the village of Haknora, located in the Narmada River Valley in Madhya Pradesh. What he found was a partial fossilized skull cap, or calvaria, specifically the top part of the skull. And crucially, it was found in geological deposits that also contain classic Acheulean lower Paleolithic tools. Dating has been complex, but estimates place it somewhere in the Middle Pleistocene, perhaps around 400,000 years ago, maybe even older.
400,000 years ago. That puts it squarely in the lower Paleolithic period, right alongside those sophisticated Acheulean hand axes and cleavers we talked about earlier. This is potentially the person who made those tools. What did the physical features of the skull cap tell us about this individual? What kind of human were they?
The Narmada fossil is classified as Homo erectus narmadensis, representing an archaic human form. Its physical features are really interesting because they seem somewhat intermediate. The estimated cranial capacity, the brain size, is quite large, somewhere between 1,150 and 1,400 cubic centimeters, cc. Now that's at the very upper end of the range typically seen for Homo erectus globally, and actually falls well within the range of modern Homo sapiens, which averages around 1,350 cc. However, other features are clearly archaic. It has a relatively flat, receding cranial vault, forehead region, compared to modern humans, and prominent, though not excessively large, brow ridges. The real significance of Narmadaman is that it represents the first and incredibly still the only substantial fossil evidence of human skeletal remains recovered from the entire Lower Paleolithic period in the whole Indian subcontinent. It confirms the presence of these advanced, large-brained Homo erectus populations in India during the time the Acheulean tool culture flourished. It connects the tools to the toolmaker.
That's amazing. One fossil connecting us to hundreds of thousands of years of tool use. Okay, so we have the fossil evidence. Now, shifting from deep-time physical remains to understanding cultural continuity and behavior, we turn to ethnoarchaeology. This seems like a really clever way to bridge the gap between past artifacts and present-day human actions.
Ethnoarchaeology is a fascinating and relatively new branch of archaeology, really gaining steam in the last 2 decades. The basic idea is to study living societies, particularly communities that still practice traditional hunting, foraging, fishing, pastoralism, or small-scale craft production, not just to document their cultures, but specifically to understand the relationship between their behavior, their technology, their social organization, and the material traces, the archaeological record, that these activities leave behind. We then use these observed relationships, these parallels, to help us interpret the often enigmatic patterns we find in the actual archaeological record from prehistoric times. It helps us put flesh on the dry bones of artifacts.
So it sounds absolutely essential for trying to understand aspects of prehistoric life that don't preserve well archaeologically. Things like how tools were actually used, how campsites were organized, the meaning behind rituals, or even something as basic as how fire was managed.
Exactly. It provides invaluable context that artifacts alone simply cannot give us. And India, with its incredible diversity of traditional communities, offers fantastic opportunities for ethnoarchaeological research, providing potential parallels or direct survivals of ancient practices. For instance, take the folklore recorded among the lodges of Kanjar, a tribal group. Researchers documented a traditional practice embedded in their stories of carefully preserving fire by keeping a special log smoldering perpetually, rather than having to constantly restart fire from scratch using friction methods. This documented practice of deliberate fire preservation strongly suggests a possible survival of prehistoric fire management techniques, giving us insight into the immense value placed on controlling fire long before matches or lighters existed.
That is a remarkable direct link across potentially thousands of years preserved in folklore. Where else do we see these kinds of parallels being used effectively?
Well, another classic example involves studying the technology of groups like the Andaman and Nicobar Islanders, some of whom maintained traditional foraging lifestyles until relatively recently. Their documented use of composite tools like hafting small stone flakes or shells onto wooden handles for adzes, or using multi-pronged harpoons made from wood and bone, provides direct analogies for understanding how Mesolithic microliths might have functioned. Seeing how these tools are made and used today helps archaeologists reconstruct the likely function and efficiency of similar-looking prehistoric artifacts made from tiny stone pieces combined with perishable materials that rarely survive. We also see it applied to interpreting art. Institutions like the Indira Gandhi Rashtriya Mana Sangrahalaya, IGRMS, in Bhopal have conducted studies among modern tribal communities living in the vicinity of the Bhimbetka rock shelters. By understanding the cultural practices, hunting techniques, seasonal migration patterns, ritual dances, and animal symbolism of these contemporary groups, researchers can develop more informed interpretations of the scenes depicted in the ancient cave paintings, potentially unlocking layers of meaning in that Upper Paleolithic and later art.
It really sounds like ethnoarchaeology adds a vital human dimension, connecting the deep past to living traditions. Okay, we have covered an immense amount of ground here, moving from million-year-old hominoid fossils right through to modern-day parallels used to understand prehistory.
It's been quite a journey. Just to quickly summarize this deep dive, we started way back in the Lower Paleolithic with those crude chopping tools, which gradually refined into the sophisticated Acheulean hand axes and cleavers, coinciding with the presence of Homo erectus like Narmadaman. Then came the Middle Paleolithic shift to finer raw materials and the dominance of flake tools, made using techniques like levallois. This led into the Upper Paleolithic, characterized by efficient blade technology, the common use of bone tools, and crucially, first flowering of symbolic expression through rock art at sites like Bhimbetka.
Then, that pivotal Mesolithic transition period, driven by climate change, saw the invention of microliths. These tiny components revolutionized hunting efficiency by enabling composite tools like arrows and harpoons, paving the way towards a more settled life, even amidst evidence of early conflict. This culminated in the Neolithic era, maybe not a sudden revolution, but certainly a revolutionary outcome. Sedentary village life based on agriculture, the development of grinding and polishing techniques for sturdy celts to clear land, and the invention of pottery for storage and cooking, with regional variations seen from Mehrgar to Burzahom to the Gangetic Plains.
Absolutely. This Neolithic stability then provided the foundation for the Chalcolithic Age, the era of copper and stone tools coexisting, marked by diverse regional cultures identifiable by their pottery, like Iharbanas, Malwa, Jorwe, and unique ritual practices like the Southern Ash Mounds. This, in turn, progressed into the spectacular urban phenomenon of the Bronze Age Indus Valley civilization, with its standardized planning, advanced engineering, extensive trade networks managed by seals, and complex religious beliefs, before its eventual decline likely due to a confluence of environmental factors.
And finally, the widespread adoption of abundant iron during the Iron Age solidified distinct regional trajectories across India. In the north, the sophisticated painted grayware culture laid the agricultural and social groundwork for the later historical states of the Gangetic Valley. While in the south, the Iron Age manifested spectacularly through the megalithic culture, with its monumental stone burials reflecting complex social organization and ritual beliefs.
So what this entire sweep hopefully shows is that the evolution of Indian civilization, while certainly complex and often non-uniform due to the subcontinent's immense environmental diversity, demonstrates this extraordinary long-term trajectory. It's a story of increasing technological mastery, growing social complexity, expanding organizational scale, and profound cognitive and cultural development, a powerful deep-time testament to human resilience and adaptation right here in South Asia.
The whole journey is just mind-boggling when you lay it out like that. But thinking about all this complexity, particularly the Indus Valley civilization, the biggest mystery, the thing that could potentially rewrite so much, remains locked away in silence, doesn't it? Considering that undeniable evidence we have for their sophisticated governance, the kind needed for standardized weights and measures, perfectly aligned town planning, managing vast trade networks. If we could finally, conclusively decipher the Harappan script, those intriguing lines of pictographic signs found on thousands of seals and artifacts, what profound political structure, or maybe economic system, or even religious ideology currently invisible to us, might suddenly be unlocked? What secrets about the foundations of their unparalleled urban success are still waiting to be read? It's definitely something to mull over until our next deep dive.